A toy manufacturer makes bikes for a profit of $12 and wagons for a profit of $10. Producing a bike requires 2 hours of machine time and 4 hours of painting time. Producing a wagon requires 3 hours of machine time and 2 hours of painting time. There are 12 hours of machine time and 16 hours of painting time available per day. How many of each toy should be produced to generate a maximum profit? First, define your objective function, or how you will determine the profit. We define X as the number of bikes and Y as the number of wagons, and Z is our total profit. For every bike we get $12 and for every wagon we get $10, making our objective function 12x plus 10y equals Z. Now let's state our constraints. First of all, we can't produce negative bikes or wagons. I'm guessing that's the equivalent of making it in the spirit world, and we're talking about the real one. So X is greater than or equal to 0, and Y is greater than or equal to 0. Now, our other constraints are our machine time and painting times. So a bike requires 4 hours of painting and a wagon needs 2, and they both must add up to 16 or less, making our painting time constraint 4x plus 2y is less than or equal to 16. A bike requires 2 hours of machine time and a wagon needs 3, and they have to add up to 12 hours or less, making our machine time constraint 2x plus 3y is less than or equal to 12. Now we graph these inequalities, and when we do, we notice a certain area of the graph has been shaded, forming a shape. The vertices are the values we will be using, and they are 0, 0, 4, 0, 0, 4, and 3, 2. We find that value by using system of equations. Plug all of these into our objective function and choose the one that generates the largest number, which is 3, 2. This means that 3 bikes and 2 wagons should be produced for a maximum profit of $56.